So today we'll be having a small discussion about inverted U-tube manometer. Earlier we have seen the working of U-tube manometer, differential manometer, and some kind of manometers. And today we'll be discussing about the inverted U-tube manometer. As the name suggests, here the U-tube manometer is there, but in an inverted position. So earlier what we had is we have a U-tube like this. Now we have an inverted U-tube manometer. So I'll show the figure. So you have the cross section of the pipe. Whenever I am drawing a circle, don't misunderstand. It is nothing but the cross section of a pipe. Pipe is coming like this, and you're connecting an inverted U-tube manometer like this. So you're using a manometer like this. Generally, what we use is this will be combined with two. It will be combined with the differential manometer. What you have is you will be having one more pipe attached like this. So one pipe may be at one level, the other will be at another level. It can be at the same level also, no issues. So what you need to find is you need to find the pressure difference at these 2 points using this differential manometer. But earlier what we have seen in whatever case we have taken, we were taking manometric fluid to be mercury. So just assume if you are using mercury, what happens? Mercury specific gravity is 13.6. Just assume that the specific gravity of this liquid is 0.8 and this is like 1.2. So what happens? Here the specific gravity is 13.6. So we know that the densest material will be at the bottom. But 13.6, if you are using mercury, what happens? It has to be at the bottom. So you cannot use like that. So here what we'll be using we'll be using the manometric fluid as a oil. We'll be using oil as the manometric fluid, which will be having very less specific gravity. So for example, just assume that this is water. And this is another liquid which is having a specific gravity of 1.5, and I'm assuming the oil is having a specific gravity of 0.8. So what happens? Oil is the lightest, so this is specific gravity is 1 for water. This is 1.5, this is 0.8. So obviously oil will be at the top, so no issues. Now just assume that you have a liquid like this. Because of the pressure, if there is more pressure, what happens? It will be exerting more pressure, so the limb goes up, and here it will be having less pressure, so the level difference will be like this. So this is how it works. The water will be entering from here and a liquid will be entering from here. Since just assuming that if it is having more pressure, it will be exerting more pressure. So this limb will go up, this limb will be coming down. So this is how it will be like. So let this difference, the level difference, let it be, for the time being, let it be 2 centimeters. And the level difference between the center of the pipe and the level, the mercury level, let it be 12 centimeter, and this level difference, let it be 5 centimeter. I'm just showing you a example for this. You have two pipes are connected with the inverted U-tube manometer, and the measurements are given as such. So you need to find the pressure difference between point A and B. PA minus PB is equal to how much? This is what you have to find. Now pay good attention that, I'm sorry for the disturbance. So pay good attention while doing numericals. This is going to be quite tricky. So you know the procedure. What you have to do is you have to find the section which is having the junction, which is at the junction between two liquids. So you have one liquid here, you have another liquid here. You have one liquid here, you have another liquid here. You can take section at any point, no issues. Either you can take section here or here, there's no issues. There's absolutely no issues. Anyway, you'll be getting the same answer. But for the time being, I'm taking the section to be here. I'm taking a section here. You can even take section here also, no issues. So I'm naming this point, the point at the first junction to be C, the point here to be C dash. So this point is C and this point is C dash. I'm just naming it like that. And I'm also taking section here, the center line, and this point let it be A dash, and let this point be B dash. That is, this point is A dash and this point is B dash. Now we have learned this. We have to check 3 things. What are the 3 things? Whether we have the same horizontal level. We have the same horizontal level here also and here also, same horizontal level. Whether it is the same liquid. You have the manometric fluid oil here and here, so no issues. Here also water and here also water. Here one liquid of 1.5 specific gravity, here also same fluid. It is continuous, there is no breaking. There is no breaking in between. From C to C dash there is no breaking. So you can assume, or you can say that PC is equal to PC dash, PA is equal to PA dash, and PB is equal to PB dash. You can say there's no issues. So this is what you can write. Let it be there, no issues. Now how to write the pressure at PA dash? This is a step. Earlier what we have written is we'll directly take this equation, we write the equation for PC and PC dash. But here what you have to do is, since it is inverted U-tube manometer, you take this point PA dash. So we have seen, if you take a container like this, it's filled with liquid. There are some points A, B, C. Out of these 3 points, which is having the highest pressure, obviously C will be having the highest pressure because it is at the lowermost point. And the least pressure will be at the top point. So A. Similarly, if you compare C and A dash, which is having high pressure, A dash or C, obviously A dash will be having pressure because in this column of water, A dash is at the bottom. So it will be having more pressure. So I will be writing what's the value for PA dash. What's the pressure? So what you have to do is you have to check the height of liquid above it. You have a height of liquid which is 12 centimeter. Then you have a point C. It is not at all exposed to atmosphere. You cannot see anywhere which is in contact with the air. So how to write the pressure at point A dash? You identify a point, that is point C. So you got PC. Obviously that pressure will be acting. Then below that, how much height is there? Up to A dash. So always when you take a point A dash, you take the height of column. And if you have a point there, that point pressure is acting, PC. Then the remaining height of liquid, that is how much height is there? 12 centimeters is there. What is that liquid? That liquid is nothing but water. So PC plus, we know the pressure equation is gamma into H. Gamma here it is water. So gamma W into height is 12 centimeter. So that is 0.12. So this is how you write the equation of pressure at PA dash. Always remember, don't get confused. You take the point A dash. At point A dash, that is having high pressure. So when you take the column of liquid, you get how much height of liquid is there, and it is not at all exposed to atmosphere, but you have a point C. So you write the point C. So pressure at C plus gamma W into this much height. You got this. But we know that PA dash is same as that of A. So you can write PA is equal to PC plus gamma W into 0.12. Similarly, you have a point B dash. So pressure at B dash. So if you have understood this level, you can write this also. So take a point B dash. You have this much height of liquid. Up to C dash, it is not at all exposed to atmosphere. So you have to consider this point C dash. But if you take C dash, what happens? Initially you have a particular liquid, then you have another liquid. So earlier also we have seen, when you have two liquid, you have to consider pressure due to that two liquids also. So pressure at B dash will be equal to pressure at the point C dash plus the first fluid. The first fluid is oil. Oil is having 0.8. So I'll write gamma into that oil. And how much height is that? That height is 2 centimeter. So that is 0.02. So this equation is nothing gamma into H. Always remember, whenever I am writing gamma into something, it is nothing but your hydrostatic equation. Pressure is equal to gamma H. This is what we are using. No, that is first liquid. Then you have a next liquid. Liquid is having a specific gravity 1.5. So that is specific gravity of next fluid. So I'm just writing gamma of F into how much height? The height is 5 centimeter. That is 0.05. I hope it is clear. When you take the point B dash, you are having two liquids. First liquid is having 2 centimeter, that is oil. The second fluid is having 5 centimeter, that is another liquid of 1.5 specific gravity. So when you take B dash, you have a point C dash. So P at C dash plus gamma of oil, that height, plus gamma of this fluid into that much height. But we know that PB dash is also equal to PB. So I can write PB is equal to PC dash plus gamma of oil into 0.02 plus gamma of fluid into 0.05. Now if you check from this equation, you can get the value for PC. So you can write PC is equal to PA minus gamma W into 1.2. Let this be first equation. Similarly, from this equation, you can write PC dash is equal to PB minus gamma of oil into 0.02 minus gamma f into 0.05. Take it to that side. So this is second equation. This is equation for PC, this is equation for PC dash, but we know that both are same. You can equate these two equations. So you can write PA minus gamma W into 0.12 is equal to PB minus gamma oil into 0.02 minus gamma F into 0.05. You know the value for gamma W, 9810. Gamma of oil is equal to 0.8 into gamma W. Gamma of fluid is equal to 1.5 into gamma W. You know everything. The only unknown is PA and PB, and what you have to find is PA minus PB. Sometimes you might get this negative. Negative means what happens is PB is greater than PA. There's nothing to worry. So if you get this as positive, it means that pressure at A is more than pressure at B. If you get this value to be negative, it means that pressure at B is greater than pressure at A. So this much Newton per meter square, you will be getting the answer. So this is how you find the measure the pressure using inverted U-tube manometer.